We're surrounded by questions all the time. Does more advertising actually lead to more sales? Does getting less sleep really tank our productivity? We all have these hunches, right? But what if I told you there's a simple visual tool that can turn those hunches into real solid clues? Well, today, we're basically going to be data detectives, and we're going to uncover exactly that. So let's just imagine for a second you're running a business. You might be wondering, hey, if I spend more on training my employees, will that actually lead to fewer customer complaints? I mean, it feels like it should, doesn't it? But how do you really know for sure? This kind of thinking applies just about everywhere. A student might wonder if putting in more hours at the library is really going to guarantee a better grade. Or maybe you're asking yourself if that new diet is the actual reason you've got a boost in energy. We're constantly making these little connections, these hypotheses in our own heads. So the big question is, how do we go from just having a hunch to getting an actual solid clue? We need some kind of tool for our investigation, right? A way to see if there's a real pattern hiding in all the noise. Well, this is our tool. It's called a scatter diagram. And really, it's just a simple but super powerful graph that lets us plot two sets of numbers against each other so we can see if there's some kind of hidden relationship. It's actually one of the classic 7 basic quality tools, and the whole point is to make data analysis easy for everybody, not just, professional statisticians. And honestly, what I love about this is how simple the setup is. So you've got two axes. The one on the bottom, the horizontal x-axis, that's your independent variable. Just think of it as the potential cause, the thing you're changing, like the hours of training. And then the one going up the side, the vertical y-axis, that's your dependent variable, the resulting effect, the outcome you're measuring, like the number of complaints. It's such a simple but powerful idea. Cause on the bottom, effect on the side. So you go out and gather your data pairs, say training hours and complaint numbers for each week, and you plot them as little dots on the graph. And this, right here, is where the magic happens. As you start plotting these points, you'll see patterns start to emerge, almost like clues appearing at a crime scene. Okay, let's talk about the first key pattern you might see. This is called a strong positive correlation. This is what it looks like when all the little dots cluster together really tightly in a line that goes up and to the right. Basically, as your cause on the x-axis goes up, your effect on the y-axis also goes up pretty consistently. A really classic example from manufacturing would be something like this. The higher the temperature of a machine, the more defects you see in the products. You see that clear upward trend? That is a huge signal telling you that you should probably investigate that temperature as a potential root cause. All right, so what about the opposite? Well, that's called a strong negative correlation. In this case, the points are still all clustered together, but now they form a line that slopes downwards. So as your cause, x, goes up, the effect, y, consistently goes down. It's an inverse relationship. For example, in a chemical process, you might find that the more iron impurity you have in your raw materials, the lower the purity of your final product. So, more of X leads to less of Y. Again, that's a really, really strong clue that something's going on there. But what if your data just looks like this, kind of like a random spray of dots with no clear direction at all? Well, guess what? This is just as important a clue. This is telling you that there's probably no correlation. It means the two things you're measuring, they likely have no real connection to each other at all. Okay, this table here is a fantastic little reference for all the patterns you might find. You can see the strong positive and negative ones we just talked about, where the dots are all packed together. But you'll also notice there are weak versions too, where you can still see the trend, but the points are a lot more spread out. And hey, sometimes the relationship isn't even a straight line, which is what we call a curvilinear relationship. Think of this as a great little cheat sheet for when you're doing your own detective work. All right, so now we know how to read the clues, but where can we actually use this thing? Well, the beauty of the scatter diagram is that it's pretty much an all-purpose clue finder. You can use it in tons of different fields. I mean, just look at this range. In manufacturing, you could be looking at machine temperature versus the defect rate. In the service industry, there's our original question, training hours versus customer complaints. In healthcare, patient wait times versus their satisfaction scores. And even in education, study hours versus exam scores. And hey, here's a little pro tip for you. You can often find even deeper clues by stratifying your data. So, for example, in that manufacturing plot, you could use different colored dots for different machines. You might just discover that one machine is the real source of the problem. Now that's taking your detective work to the next level. But now we've come to the single most important rule of this entire process. Seriously, if you remember only one thing from this, make it this next part. And here it is. Correlation does not imply causation. Just let that sink in for a second. This is the absolute golden rule of data analysis. Just because two things look like they're related on a chart, it does not automatically mean one is causing the other.
I want you to think of it this way. A strong pattern on your diagram is a clue, but it is not a confession. It's just pointing a finger and saying, hey, look over here, something interesting is going on.
All it does is tell you where you should investigate further. It is not the final answer. It helps you narrow down your list of suspects, but you still have to go out and gather more evidence. The next logical step is often to run a controlled test or maybe a designed experiment to actually prove that a real cause and effect relationship exists. So, like any tool, right, it has its strengths and it has its limitations. The real beauty of it is its simplicity. It's visual, it's clear, and it can give you a powerful clue almost instantly. But on the flip side, you got to remember it only looks at two variables at a time, and it can never prove causation. And, maybe most importantly, you need to have enough data to even trust what you're seeing. So, how much data is enough? Well, a good rule of thumb is that you want at least 30 to 50 data pairs to really see a meaningful, reliable pattern. If you have any less than that, you might just be looking at a coincidence, not a real correlation. So, after all this, why does this simple little tool matter so much? Why is it considered, a cornerstone of quality management? It's because it empowers anyone, not just statisticians, to start making data-driven decisions. It gives all of us a way to move beyond just guesswork and gut feelings and to start looking at the actual evidence. So, I'll leave you with this one final thought. What important relationship is out there in your world, maybe it's at your job or with your health or even in one of your hobbies, that's just waiting to be understood? Because you now have the perfect tool to go out and start your investigation.